What if the most powerful chip of tomorrow didn't just calculate, but actually thought more like a brain? For decades, we've depended on traditional processors to power our phones, computers, and the internet itself. But these chips demand enormous amounts of energy and still can't match the speed and efficiency of biology. That's where a revolutionary new chip comes in. One so tiny it fits on your fingertip, yet powerful enough to transform technology in 2026 and beyond. Let's get started. Number 1. From traditional chips to a new era. For decades, the backbone of modern technology has been the traditional silicon chip. These processors power everything from smartphones to supercomputers, running billions of calculations every second. But as powerful as they are, they come with a major limitation: energy consumption. The faster they become, the more electricity they demand, often generating heat and requiring cooling systems. Meanwhile, our daily reliance on AI, data centers, and connected devices is only growing. If this trend continues, energy use could spiral out of control. That's why researchers are searching for something radically different. A chip that doesn't just process information, but does so efficiently. By mimicking the human brain, neuromorphic chips could be the answer, opening the door to smarter, more sustainable computing. Number 2. Why the human brain remains unmatched. Your brain is the most powerful and efficient processor ever created. It only consumes about 20 watts of energy, less than a dim light bulb, yet it can handle perception, learning, decision-making, and creativity all at once. Compare that to modern GPUs, like those made for artificial intelligence, which consume up to 1,000 watts to complete narrow tasks. Even the brain of an owl, running on less than a watt, can outperform supercomputers in processing vision and flight coordination. Scientists realized that instead of pushing traditional chips to their limits, the better path forward was to learn from biology. If we can replicate even a fraction of how neurons fire, adapt, and learn, we can build chips that are both powerful and sustainable. Number 3. Introducing Pulsar, a brain-inspired chip. Enter Pulsar, a chip developed by Dutch company 𝐬𝐻𝐫𝐞. This processor is just 3 millimeters wide, small enough to fit on your fingertip, yet it packs remarkable capabilities. Pulsar mimics how the brain works, using artificial neurons that fire only when needed, saving energy in the process. Unlike traditional CPUs that separate memory and processing, Pulsar merges the two functions in each neuron, just like the brain. Although it only contains about 1,000 neurons, tiny compared to the human brain's 86 billion, it's already enough to perform advanced sensor tasks in real time. This means devices with Pulsar could recognize images, process sound, and detect motion, all while using almost no power. For such a small package, its potential is enormous. Number 4. How neuromorphic chips function. Neuromorphic computing isn't just about building smaller chips. It's about rethinking how computation works. In a regular CPU, memory and computation are separated. One stores data, the other processes it. But this back and forth wastes time and energy. Pulsar solves this by combining both in each neuron using resistive memory. When signals arrive, current flows directly through these memory points, automatically performing the multiplication and storing the results. This makes processing instant and highly efficient. It mirrors the way biological neurons and synapses learn from activity, growing stronger or weaker depending on experience. With this design, neuromorphic chips can handle tasks traditional processors find exhausting, such as real-time pattern recognition or decision-making in unpredictable environments. It's computing, inspired by life itself. Number 5. Spiking neural networks, event-driven power. One of Pulsar's most unique features is its ability to run spiking neural networks, SNNs. Unlike normal AI models that constantly compute, SNNs only activate when events occur. Think of it like your senses. Your ears don't react to silence, only to sound. Similarly, SNNs remain silent until something interesting happens, such as movement or a sudden change in data. This makes them incredibly efficient. For example, a camera running on SNNs doesn't waste energy capturing every frame. It only responds when something moves across its view. This event-driven style of computing makes SNNs perfect for low-power devices like security systems, wearable trackers, and robotics. By cutting out unnecessary activity, Pulsar's SNNs bring the power of human-like responsiveness into machines. Number 6. Convolutional neural networks, recognizing patterns. While spiking neural networks handle events, Pulsar's second brain uses convolutional neural networks, CNNs, to identify patterns. CNNs are essential for tasks like image and speech recognition, allowing machines to understand data much like humans do. They work by scanning inputs, detecting features such as edges, shapes, or textures, and piecing them together to form complete patterns. For example, even a messy sketch of a cat can be correctly recognized. By combining CNNs with SNNs, Pulsar can both react instantly to events and understand complex patterns. This combination enables smart cameras, speech processing devices, and robotics to operate efficiently while conserving energy. Number 7. Real-world applications of Pulsar. Pulsar's efficiency and intelligence make it ideal for a wide range of real-world applications. Imagine phones and laptops that last for weeks on a single charge, or smart cameras that record only when meaningful activity occurs, saving energy and storage. In healthcare, wearable devices could monitor heart rates, breathing, or neurological signals in real time, alerting users instantly. Industrial robots and factory systems could detect defects or hazards immediately, improving safety and productivity. Even everyday items, from appliances to clothing, could gain intelligence. By embedding tiny, brain-like chips, technology around us could become more responsive, energy efficient, and capable of learning from the environment. Number 8. The challenges of scaling up. Despite its promise, Pulsar faces significant challenges, the first being scaling. Currently, it contains around 1,000 neurons, enough for simple tasks, but far below the billions needed for complex computation. Adding more neurons introduces parasitics, unwanted electrical interactions that reduce efficiency and precision. Another major hurdle is software support. Traditional chips benefit from decades of programming tools, while neuromorphic computing requires specialized coding skills. Most training still relies on conventional computers. Without robust software, even the most advanced hardware can remain underutilized. Solving these challenges is essential before brain-inspired chips can be widely adopted in robotics, sensors, healthcare, and everyday smart devices. Number 9. Competition in the chip industry. The chip industry is one of the fiercest battlegrounds in technology, with giants like NVIDIA, Intel, AMD, and Apple constantly pushing limits. Each year, they release faster processors and GPUs to meet the exploding demand for artificial intelligence and data processing. But this race consumes massive energy, leaving space for brain-inspired chips to stand out. Companies like Inatera face tough competition, not only from big names, but also from smaller startups racing to prove themselves. The challenge lies in balancing performance, cost, and adoption. Whoever masters low-power, brain-like computing first could reshape the entire industry and become the leader of the next tech revolution. Number 10. The future of brain-like chips. The future of brain-inspired chips like Pulsar looks promising and potentially world-changing. As billions of new devices, from smart homes to medical wearables, come online, efficiency and speed will matter more than ever. Neuromorphic chips offer both, allowing devices to think locally without relying on energy-hungry cloud servers. This could reduce global energy consumption while enabling real-time decision-making in robotics, healthcare, and consumer technology. Pulsar is just the beginning. Future versions with millions of artificial neurons could rival biological efficiency on a massive scale. By 2026 and beyond, brain-like chips may no longer be experimental. They could become the foundation of everyday computing. The chip that thinks like a brain could soon change how our world works, making devices smarter, faster, and far more efficient than anything we've known. From powering everyday gadgets to shaping the future of AI, this breakthrough shows us what's possible when technology learns from nature. If you enjoyed this journey into the future of chips, don't forget to like and subscribe for more. Thanks for watching, and until next time, stay curious and inspired.